All right, so this is lesson 2-3, and we're going to be looking at synthetic and long division. So our learning target is that you can rewrite simple rational expressions in different forms, including the use of synthetic and long division. So for the first video, I'm just going to focus on long division. And then for the second video, I'm going to focus on synthetic division. All right, and so when you look at long division, here's our first example. You need to think about, just back to basics. Okay, what did you learn when you were in elementary school? So think about long division. If I had 247 divided by 2, I would say, okay, 2 goes into 2 one time. Then what would I do? I'd multiply, right? 1 times 2 is 2. Well, I didn't add this, I subtracted it. And then that would cancel out, and I'd be left with 47. Then I'd do it all again. I'd say, okay, 2 goes into 4 how many times? 2 times. Well, then what would I do? I'd multiply. 2 times 2 is 4. I'd subtract it. That would cancel, and I'd be left with 7. And then 2 goes into 7 3 times. 3 times 2 is 6. Subtract it to get 1. Well, then the problem is 2 doesn't go into 1, right? So we have a remainder. And so this would be, like 0.5 or 1/2, something like that, 123 and a half. All right, so that's back to basics, back to elementary school. So that whole process that we just experienced, we're fixing to do again, but this time we're going to have good old polynomials. All right, so I'm going to set this up, and it's going to be 2x squared minus 3x plus 1 divided by x plus 5. All right. Now, when you do this problem, you always look at the first terms. All right. So this is my first term, and this is my first term. So x goes into 2x squared how many times? It's easier to think about that as what could I multiply x by to get 2x squared? And it would be 2x, all right, because 2x times x is 2x squared. So I'm going to multiply, but you don't just multiply the first term, you have to multiply it to both. So it's kind of like distribution. So we have 2x squared and then 10x. All right, now this is where things are going to get a little weird. All right, remember, this doesn't cancel out unless you subtract it. But when you subtract a polynomial, you're really distributing that negative, which ultimately just changes the signs. All right, so instead of this being positive, it becomes negative. Instead of this being positive, it becomes negative. Now, I'm circling those because I want to differentiate when I've changed my signs. Like if I go back to that problem, or somebody walks in my room and says something to me, then I want to remember that I've done that. All right, because it's a real easy way to make a quick mistake. All right, so ultimately, subtracting makes your signs change. I circle it just to make sure that I remember that I have already taken care of that part. So now this first term will cancel. This gives me negative 13x, and then the 1 drops down. All right, now I start the process over. Okay, I'm like, okay, first term. Well, what can I multiply x by to get negative 13x? And it would be negative 13. Didn't mean to change my color. All right, but either way, I'm distributing to both terms. So that would be negative 13x, and then this would give me negative 65. Be careful. Common mistake is we're like, oh, cross it out. Oh, that's negative 64, but then you'd mess it up. All right, so that's not the case. So we need to change our signs. So this is going to become a positive, and this is going to become a positive. All right, so now this cancels finally because it's a negative and a positive, but then this gives me 66. Now, x can't go into 66, so that means this is my remainder. So how we write that is we keep this 2x minus 13, but then we say with a remainder of 66 over whatever you were dividing by in the first place, x plus 5. So this is my answer. All right, so let's look at another one. All right, so in this one, we're going to set this up. X minus 1 is being divided into 3x squared minus x. I'm going to put minus 1x just because that's going to help me a little bit later, plus 4. All right, so the first term right here, x and 3x squared. What can I multiply that to get that? 3x. So now I have to distribute that 3x, right? So 3x times x is 3x squared. 3x times negative 1 is negative 3x. But because we're subtracting, that's like distributing a negative. So this changes signs, and this changes signs. All right? Now, this cancels, and we combine to get positive 2x. We bring the 4 down. Then we start over. All right? X times what gives me 2x, and it's positive 2. So I distribute. 2 times x is 2x. 2 times negative 1 is negative 2. But I've got to distribute that negative because I'm subtracting, so that changes my signs. Again, I circle it because it helps me remember that I've done it. All right, this cancels, leaving me with 4 plus 2, which is 6. So that's my remainder. So I come back up here and I say 6 over x minus 1. And that's my answer. All right, I do want to caution you as well that sometimes you'll have missing terms. And if you were to have a missing term, you would fill in a 0 as a filler. So we're going to see that in this next example. All right, so in this next example, I want you to notice that right here it goes 4, 3, and then there's no x squared, right? There's a missing term. So we're going to fill in a 0x squared. You want to have a filler. That's the only term that's missing, okay? It doesn't matter so much in this, but it does matter over here because it kind of serves as like a placeholder. So I'm going to have x squared plus 1 divided into 1x to the 4 minus 3x cubed plus 0x squared minus 2x plus 1. Let me slide this over a little bit. All right, so I'm going to do the same thing I've been doing. I'm going to start off with the first term. So what can I multiply x squared by to get x to the 4? And it would be x squared. Okay, I'm just kind of lining things up. So I'm going to multiply because this has to, everything always has to get distributed back, okay? So x squared times x squared is x to the 4, 1x to the 4. X squared times 1 is x squared, but I'm lining it up, okay? That just makes combining my like terms a little bit easier. Again, remember, this doesn't cancel. I have to change the signs because really I'm subtracting, which means I'm distributing a negative, and then my signs end up changing. So this first term now cancels. I have negative 3x cubed minus 1x squared. Bring all this other stuff down. So minus 2x plus 1. And then we start over. So x squared times what gives me negative 3x cubed? Well, it would be negative 3x. Now I'm going to distribute. Negative 3x times x squared is negative 3x cubed. Negative 3x times 1 is just a minus 3x. Again, make sure you're lining things up. Because I need to subtract all of this, it's like distributing a negative, which changes my signs. Now this cancels, leaving me with negative 1x squared, positive 1x, positive 1. So x squared times what gives me negative 1x squared? Well, it would be a minus 1. Distribute, negative 1x squared. Distribute, negative 1 times 1 is negative 1. All right. So I need to subtract all of this, which means I'm distributing the negative, which means my signs do what? They change. Okay. Again, I like to circle it because it reminds me that I've taken care of that. Because sometimes you'll get confused, like, well, what was the sign? Oh my gosh, I can't even remember if I've done it, right? So that does really help. So this first term cancels, leaving me with 1x plus 2. Well, x squared doesn't go into x, so this whole thing is my remainder. So I come up here and I put my remainder, x plus 2, over the x squared plus 1, whatever I was originally dividing by. And that is my final answer. All right, now that's just 3 examples. Obviously, I could keep going. So this was a great example. It had a missing term, right? So I had to have that filler term. So if you don't do that, that could totally throw you off. So make sure you have a filler term. And then sometimes you don't even get a remainder. If everything cancels out and you get 0 for the remainder, then you just wouldn't write this portion right here. You would just leave it like that. Like if there was a 0 remainder, you would have no reason to write the remainder. All right, so those are some examples of dividing polynomials using long division.